the first tutorial from section 5.5, we have one objective, which is to work out the gradient of a straight line perpendicular to the line y equals mx. That means to get the gradient of a straight line which makes a right angle with the line of form y equals mx plus c. Before proceeding with that objective, let's take a smaller objective, which is how to define the relative position of the two straight lines. When are these lines parallel? When are they intersecting? And when are they perpendicular? Again, this objective is in section 5.5 and it is to work out the gradient of a line that is perpendicular to the line y equals mx plus c. Let's take example number 17. Work out whether these pairs of lines are parallel, perpendicular, or neither. Before explaining this chart, let's take a chart that shows the relative position of two straight lines. Given the two straight lines D of equation y equals mx plus c and another straight line of equation D prime where y equals m prime x plus c prime. I have to determine the gradient for these two straight lines, and as we know that the gradient is the coefficient of x as shown here. So the gradient of D is the coefficient of x, which is m, and the gradient of D prime is m prime. If the two straight lines are in this position as shown here, this means that there is no intersection point between them. Therefore, the two straight lines are parallel, so no point in common between them. So, if I return to the basic form or position, we can notice that m equals m prime, so the two gradients are equal. Therefore, if I have two straight lines and there is no point of intersection between them, then these lines are parallel, which means that they cannot intersect with each other, and in this case, their gradients are equal. However, if they are not parallel, then one line will intersect with the other, forming a point of intersection. In this case, these two straight lines are called intersecting straight lines, and this is the opposite case of the parallel. So the gradients are not equal. Therefore, m is different than m prime. For a special case of intersection, the angle between the two straight lines may be acute, which is less than 90 degrees, or obtuse angle, which is greater than 90 degrees, as this angle. While if the angle between these two straight lines is a right angle, which is equal to 90 degrees, then this is a special case. We call these intersecting lines perpendicular straight lines. Perpendicular means that the angle between the two straight lines is equal to 90 degrees. In this case, not only m is different than m prime, but also there will be a mathematical relation between the gradients. So m equals minus 1 divided by m prime, and m times m prime equals minus 1. This is an important chart. Let's repeat again. If the two straight lines are parallel, then there is no common point between them. So to connect the shape with the rule, parallel shape is like the equal sign, so the gradients are equal. If the two straight lines are not parallel, so they are intersecting lines, and in this case, m is different than m prime. And sometimes intersection lines could have a special case which we call perpendicular lines, which are two straight lines forming a right angle between them, and the product of the two gradients is minus 1. M times m prime equals minus 1. Let's return to section 5.5 on page 84 that if a line has a gradient of m, a line perpendicular to it has a gradient of minus 1 divided by m. As we have said before, in this case, m prime will be equal to minus 1 divided by m. Then, if the two lines are perpendicular, then the product of their gradients is minus 1.